Assalamu alaikum. Today we are going to discuss about the electrical properties of membrane. So what are the different electrical properties which membrane is having? So as we know, our cell is is surrounded by the cell membrane. This cell membrane is composed of the lipid bilayer and embedded with the proteins. It are intrinsic, extrinsic proteins. So the complexity of the cell is quite high. If we will forget about all the organelle complexity, keeping things aside, if we will simply talk about the ions which are present in the cell and the ions which are outside the cell, or we can say we will simply consider this cell as a little bag formed by the cell membrane and is filled with the saline. So if we will talk, so this saline, the components which are present in the salines will be varying from the outside the cell to the inside the cell. As we all know, the plasma membrane is having two components, like we are having hydrophilic part of the plasma membrane and the hydrophobic part of the plasma membrane, and they constitute the phosphate lipid bilayer. Phospholipid bilayer. So if we'll talk about the hydrophilicity of the plasma membrane, they are watery loving and are surrounded by the water molecules. So the other end of the lipid is the hydrophobic. As name indicates, it hates to be close come in the contact with the water, so they remain away from the water. So hydrophilic is water loving and the hydrophobic part is the water hating, due to which there is this is the membrane formed by which, due to which there is a difference in the ion concentration. As we can say, this is one of the characteristic feature of the living cell that controls the exchange of electrically charged ions across the membrane. So we can therefore call this as the electric. This generates the electric potential from inside to the outside. We are having different types of molecules or particles which are present inside or outside the cell. These are anions and the cations. Anions are the negatively charged particles, whereas the cations are the positively charged particles. If we will talk about the basic molecular gradient, if we will take the example of the nerve cell, we know that outside the nerve cell we are having higher concentration of sodium, lower concentration of potassium, higher concentration of magnesium, like that. So the concentration of sodium outside the cell is 142 millimolar, while if we will take example of sodium inside the cell, it is 14 millimolar. Potassium outside the cell is 4 millimolar, while inside the cell it is 140. So like that, there is the molecular gradient in the cells which are responsible for the membrane potential. So these concentration gradients provide the potential energy which drives in the formation of the membrane potentials. We are having different types of ion transporters or proteins pumps present on the membrane, due to which or due to through the ions are moving from outside to inside and inside to the outside. So if we will talk again in the ionic concentration, outside the cell we are having higher concentration of sodium and chlorine, while potassium is in low concentration, and vice versa. In the cell, in the inside the cell, we are having higher concentration of potassium, low concentration of sodium, and low concentration of chlorine ions. So signals are generated by opening and closing of ion channels at one point in the membrane, producing a local change in the membrane potential. When these ion channels are opened up, they give signal to the membrane, which are responsible for the membrane potential. So the membrane potential can be measured in conductance, like if we will talk about the conductance of a pure phospholipid, they are very good insulators. So if we will talk about the conductance of a membrane per unit area, it has been estimated that it is 10 raised power minus 13 per ohm per meter square. So the conductance of a biological membrane is much higher, typically by several order of magnitude, even at the rest. So there are, as we said, that there are many pores, ion channels, which are responsible for the movement of the ions. So when there is a change in the concentration, or when there is the electric potential generated, they lead to the capacitance of the cell. So if we will separate a charge Q by applying the electric potential V across the membrane, then we can say the capacitance of the membrane can be defined as Q by V. So Q represents our charge by electrical potential, gives our capacitance of the membrane. So if we will talk about the membrane potential now, the another property of the membrane. So the experiment has been conducted in giant squid axon, where it's said that the resting membrane potential is when the membrane is not in the excited state. So we can say resting membrane potential मतलब होता है जब हमारे पास कोई सिग्नल नहीं होता है, और when our membrane is not in the excited state. So in case of giant squid axon, experimental has been conducted. It has been observed that the resting membrane potential has been found to be minus 70 millivolts. But it has said minus 70 millivolts. As we know, the sodium potassium is the main ion channel in the membrane of the resting neuron that is responsible for the generation of the voltage across the membrane. So sodium potassium is responsible for the generation of voltage across the membrane. So if we will talk about the membrane potential of potassium at the equilibrium, its value is minus 91 millivolts. So potassium are inside the cell and the sodium is outside the cell we are talking about the axons. So outside the cell, the sodium equilibrium potential is having value of plus 55 millivolts. As earlier I said that the resting membrane potential is minus 70 millivolts. So we can say that it is having similar sign and magnitude to that of the potassium equilibrium potential. Like we have observed resting membrane potential minus 70 millivolts. For potassium equilibrium, we have observed minus 91 millivolts. As in this diagram, we have taken a voltmeter which will detect our difference in the voltage. So first the recorder and the reference electrode is outside the membrane, which is having 0 voltage. But when the recorder electron was inserted into the axon, it was recorded that the membrane potential is minus 70. This was the experiment carried out on the membrane to know the membrane potential. So this is the how action potential takes place. So if membrane of the squid is stimulated, now we was earlier what we said right now, membrane resting membrane potential. Now the action potential, when the nerve or when there is stimulation in the axon, the sodium channels open up, so sodium ions are moving into the cell. This reduces the membrane potential, means there is now positive ions are coming in, because this positive charge in the membrane potential causes decrease in the polarity between the two sides of the membrane. It is called as depolarization. This depolarization stimuli will be only for will the potential or membrane potential of the membrane will get decreased by only few millivolts. Then again rapidly it will come to the resting potential. If I will give stimuli, again I will repeat, if I will give stimuli, the sodium channels will open up. They will allow sodium to come into the membrane. This reduces the membrane potential, making it less negative. Because of this positive charge in the membrane potential causes decrease in the polarity between the two sides of the membrane, as its depolarization. So there is only a few millivolt decrease in the membrane stimuli, and it will disappear soon. But it has been observed that if the membrane potential crosses certain point, if it is reaches up to minus 50 millivolt, then the series of events occur. मीन्स अगर ये पहले क्या होता है, थोड़ा सा सोडियम अंदर आएगा, देयर इज छोटी सी डिफरेंस हो जाएगी मेम्ब्रेन पोटेंशियल बाय फ्यू मिली वोल्ट्स. लेकिन अगर एक थ्रेशोल्ड लेवल के बाद जैसे हमारा वैल्यू चेंज हो रहा है अप टू द माइनस 50 वोल्ट, देन at that point the series of events occur. Increase in the voltage beyond the threshold causes voltage gate sodium channels to open up, resulting in the free diffusion of sodium into the cell, as you can see in the diagram. Into the cell their concentration and electrical gradient till the membrane reaches voltage up to plus 40 millivolts. If we are talking about the plus 40 millivolts, this is the equilibrium gradient of the sodium channel. So after 1 millisecond, sodium channel spontaneously inactivates. Then when this inactivates, then the calcium channels open up. As a result, calcium ions move freely from outside when the sodium is there, it inside the cell, it inactivates its channel proteins or channels of the ion channels. So as the membrane reaches voltage of plus 40 millivolt, so sodium channels open at that time. Sodium ions move freely outside the cell down their concentration and the electrical gradient till the potential reaches up to the minus 80 millivolts. So if we will collect all the things together, collectively all the changes in the membrane, means action potential or the depolarization, polarization, these are collectively called as action potential of the membrane. Action potential lasts in, it has been observed experimentally that the action potential of the squid axon lasts for 5 milliseconds, and it in case of mammalian myelinated neurons it is less than 1 millisecond. It is less than 1 millisecond. This was the introduction or properties of the electrical properties of the membrane.